we enclose the variable inside double quotes, like so. We say test, and then var1, instead of var1 by itself, we put var1 surrounded by double quotes. Now, it's actually a really good idea to make this a good practice. Do this, well, all the time, unless you can absolutely guarantee that var1, or whatever variable you're using, has actually been set to something. If there is even the remotest 1 in a million possibility that the variable you're testing might not have been set yet, then you must put double quotes around the variable, otherwise you'll get a syntax error with test. So let's have a look at our example again. So now we say test $x equals 20, and we did not get any syntax error. Let's find out whether it is 20 or not. Well, it's not 20. 1 means false, remember? Now, the reason that this actually works when it didn't work before is, well, let's have a look at it. The shell comes along as before and looks for special characters on the line. It finds the $x and removes them completely, so we essentially end up with just 2 double quotes next to each other, enclosing nothing, if you like. Now, we call this the empty string. Now, technically, the actual double quotes are removed as well, so you might think, well, we're left with completely nothing, like we were left with before. But, interestingly enough, the shell actually treats the empty string as something. It treats it as a parameter. So when the test program runs, it'll find that it actually has 3 parameters after the word test. It'll have an empty string followed by an equal sign followed by a 20. And that's what test needs. It needs 3 parameters in this particular case. Whereas before, when we didn't have the double quotes around it, it would only get 2 parameters, the equal sign and the 20. It's a very subtle thing, I know, but if you don't really understand it, that's okay. Just keep in mind that you should always enclose your variables inside double quotes if there's any chance that the variable might not be set, or might be set to nothing. Anyway, let's move on and have a look at some more options that test offers us, some ways that we can use this very useful program called test. So some of the useful options for test are as follows. We've already seen test whether one value equals another. The test will return a 0, which we can interpret as true if the values are in fact equal. And then we've got the not equal or different, which is an exclamation mark before the equal sign. That's the symbol for not equals in the shell programming language, or rather in the test programming language. We've also got greater than, GT, minus GT, which will actually only work if both value 1 and value 2 are integer values or numeric values. If one of them is non-numeric, you'll get an error message from test. And we've also got minus LT for less than, minus GE for greater than or equal to, and minus LE for less than or equal to. What else have we got? Well, we can just say test value by itself, not really comparing it to anything. And what we will actually get back is a true-false value, and it will be true if the value is actually non-empty. In other words, that variable, if there is a variable, has been set to something. Now, obviously, if you're testing that, then there's obviously a chance that it might not be set to something, and if that's true, if that is the case, that it might not have been set to something, then you really need to enclose value in double quotes. Now there is an opposite test for that as well, test minus Z or Z. Z stands for 0, and this will actually return true if the value is empty. It is of 0 length. So those are a bunch of options for testing the values of variables and comparing one variable to another. We also have some other options that can be used with test, and they actually really have nothing to do with variables per se. They have to do with files and directories. So let's have a look at those. We've got test minus F. Notice that the minus F is actually the first parameter to test. Now this returns true if the file that you specified exists and is a regular file. In other words, it's not a directory or a device or something like that. And we've also got test minus D, which is exactly the same, but it will actually return true if the file exists and is a directory. If it's just a regular file, then it will return false. We've got a couple of other options. We've got test minus S, which will return true if the file exists and has a file size greater than 0. Now it doesn't actually test to see whether it's a regular file or a directory or anything like that, it just tests its size. Directories too can have a size, so bear that in mind. And then we've got test minus R or test minus W or test minus X, which will return true if the file exists and is readable or writable or executable, depending on whether you specified minus R or minus W or minus X. And it will only test to see whether it's read, write or executable by the current process, meaning that the file may indeed be writable, but if it's not writable by this shell script, then you'll get a false value. Let's have a look at some examples of those. We'll do a test minus F of slash etc slash password like that, and we'll echo the result out like that, and that is a regular file. We'll do a test minus F of slash 123 slash 456, and that turns out to be not a regular file. We can test for a directory. We can just test the current directory like that and echo $? Or we can set a value, a variable called dir to be slash etc slash, I don't know, garbage, and then we can test whether that directory exists, like so. And of course it doesn't. Now we'll see if the slash etc slash password file is writable by us. Let's check that out. That's test minus W slash etc slash password, and it is not writable by us. So that's a collection of handy options for test.